It's a bomb because all reaction can occur. You want to carry two bombs close to you, or you want it to be away from you. You want it to be away from you so that no reaction will occur, the best. So nature also know they want to have two single bonds separate them. If this one is too close, oxygen will look for it, the free radical will look for it and attack it anytime they can find it. These are high density electron area. Okay? So if you ask me, this kind of structure appear in fatty acid? Yes. During heating, migrations of double bond always occur. They migrate from line, they migrate closer to each other, then they start to explode. When they explode, oxidation occurs. So migration is very common to conjugate it. So these are important messages that I want to share with you. We also have, it's not here, N3 in your notes. We also have N3, linolenic acid. Okay, 3 double bond. The first one appear, number 3 is an omega 3. If you refer to your notes, 3, 6, 9. Nature. Okay, they won't have 3, 5, 8. And they don't have this kind of structure. They will have 3, 6, 9, 12. With 4 double bond, 3, 6, 9, 12. 5 double bond, 3, 6, 9, and so on. So this kind of structure depends on the number of carbon. Okay. So, and these are conjugated. I already mentioned. These are non-conjugated. Nature always occur non-conjugated. 2 double bond, 2 single bond separated the 2 double bond. Right? Non-conjugated. So because of double bond, you always think that unsaturated is more reactive. All kind of chemical reactions can occur. Right? So in nature, you have 2, 3, 4, 5, up to 6 double bond. Okay. 6, 5 normally occur in marine oil, fish oil. Okay. If you take a look at the melting property, we cannot measure the melting property. It is so low that you don't know what is the temperature of melting, because, for example, 4 double bond, the melting temperature is minus 50. This one perhaps minus 100, minus 200 is the melting point. So this all normally present in 5 double bond, 6 double bond, normally present in fish oil. The melting temperature is very low, especially, it's very hot, especially deep sea fish, okay, deep sea. My questions will be, why deep sea fish require this type of double bond? In river, normal river fish have very less this. Why deep sea fish have very high omega 3 type of fatty acid? Yes. Deep sea water is very cold, minus 10, minus 20, minus 30 degrees, depends on where the fish go. So if they have this type of fatty acid, double bond, okay? At that temperature, what happened to the fatty acid? Solid clot. Suddenly the fish died because no flow of blood, because the fatty acid solidified. So they must have a lot of liquid fatty acid in the body. These are the nature. Okay. So, but because they are very reactive, Therefore, plant source don't want to carry. They are too reactive. They carry 5 bonds in the body or 6 bonds in the body. It's very dangerous. Most of the plant kingdom don't want to carry it. It's only fish oil carry it. Right? So if you take a look at the fatty acid, oleic is the one present naturally. Okay? 16.3. Linoleic minus 6.5, right? Linoleic melting point. How about stearic acid? Anyone name it stearic acid melting point? Go back to the saturated table. Melting point. Melting point. What is the melting point? Yes? You have it right in the table. So what I want to show here is that when I say fatty acid is very important, if you take a look at this physical property, these are physical properties. No double bond, melting point 70. Single double bond drop to 16.3. Extra 1 minus degree, the melting point. So this, a tiny double bond, has such a great effect on the melting profile. Okay. The chemical structures is almost the same, only 1 double bond extra. The melting behavior is different. Therefore, double bond presence in fatty acid play a very important role in all kinds of reactions. Okay? So I would like to also share with you, go back to a little bit on geometrical and positional isomer for unsaturated fatty acids. You have geometrical isomer and you also have positional isomer. You learn this in organic chemistry, right? What is geometrical isomer? For protein or carbohydrate, you don't have this problem, but for lipid, you always have this. Geometrical isomer. Cis and trans. Which one is trans, which one is cis? This one? Cis. This one trans. My next question is, nature have cis more or trans more? Cis. Nature prefers cis. Okay? Cis and trans is a very unique structure. One, they give you this structure just because of H different. And just now I already mentioned, without double bond and with double bond, physical property very different. Geometrical isomer also very different. Another question is asked. The same chemical structure, molecular weight, cis or trans having higher melting point? Trans. Are you sure? Trans. Why trans? Why trans? Solid, why saturated fatty acid melting point is very high is because the change is short and is straight. Okay. The change is straight line because no double bond. When it is straight line, all the fatty acids stand together. Heat penetration is very difficult. Therefore, the melting point is higher because of compactness. Okay. You have double bond. You have two double bonds. You have more. The structures is no longer in straight line because H stay one side. Normally it's cis form. H stay one side. So these are the structure. Okay. This kind of structure is very difficult to pack when you have straight line, which is paper, pieces of paper. You want to stack them, it's very easy. When the paper is folded, you want to pack it, it's difficult. When it is difficult, when you want to heat it, heat penetration is very easy because there are a lot of empty space, easy to spread them. So therefore, for this kind of structures, the melting point is very low. Okay. The issue now related to trans. Why trans melting point is high? Because trans structure is always like that because the H stays this side. It is also straight line. The H doesn't stay in one side, it is straight line. Therefore, to pack them, trans is very easy to pack and difficult for heat to penetrate. Okay? Therefore, if you take a look at the example table just now, oleic acid and allylic acid. Allylic acid occur in partially hydrogenated fat. Okay? 9, 9, 18, 1, 18, 1. Am I right? These are same position, double bond and carbon number 9. Why they have different name? One we call oleic acid, one we call allylic acid. Why? Cis, trans. Cis and trans. Cis melting temperature 16.3. Trans temperature 43.7. Almost triple, 3 times higher. Just because of positions, geometrical isomer. Okay, so these are chemistry of liquid but play a major role in physical properties. Right? So we also have this arsenic, what do you call it, acid. 18, one double bond. Double bond appear at carbon number 11. When it is appear at carbon number 11, 18, 1, you call it what kind of isomer? This 2 is geometrical isomer. This 2 is positional isomer. Plus, they are also geometrical isomer. Why? Because one is 9, one is 11, positional different. So-called positional isomer. One it is cis, one it is trans. Therefore, it is called geometrical, both positional and geometrical isomer. Is it clear? Alright? So therefore, the melting point is almost the same as this because these are straight line structure, trans. Okay? So I summarize here. These are cis structure, HH. These are trans structure, straight line. Okay. So I already mentioned allylic and oilic are cis. Okay. Whereas if you take a look at basinic, are both positional and geometrical isomer of oilic acid. Right? So we also have others. For example, petrosalanic acid, parsley seed. You know parsley? The type of herbs, parsley seed. Or they have cis 6, which means that the double bond appear at carbon number 6, not carbon number 9. So these are positional only, not geometrical because both are cis. Okay, so position. Right? So that's it for our chemistry of liquid. Is it a lot of information or
That's a lot of information.
is it the one that you already know? Most of the knowledge you already know, right?
Yeah.
You already learn, right? So it's just a recall, right? Review. So I hope that you can digest it quickly and then we are ready to embark into the processing time. So another small, before we break for lunch, so just a small information I want to share with you. Although